For any given risk, there are multiple possible outcomes, and each of them will have their own probability of occurring. In this lesson, we'll talk more about these groups or collections of probabilities and some important characteristics that apply to these kinds of statistics. As mentioned before, one of the most important considerations when prioritizing your risks is the likelihood that the particular risk will actually result in a loss. For example, a business that has lots of physical inventory should devote a lot more attention to physical hazard risks such as fire or flooding when compared to a service-based company whose employees work from home. To analyze the probability of something, you'll normally start by identifying all the possible outcomes associated with that situation, risk, or event. This entire set of all the possible outcomes is collectively referred to as a distribution. When you include the probability for each possible outcome, the resulting table, chart, or graph is then referred to as a probability distribution. Now, all probability distributions have to satisfy two basic requirements. The first is that all the possible outcomes have to be mutually exclusive from one another, meaning that any time an instance or occurrence happens, it can only be one of the listed possible outcomes. In other words, the result or occurrence can never simultaneously be more than one of the outcomes. For example, when you roll a single six-sided die, the result of the die roll will always be only one of the numbers from 1 to 6. It's impossible for that die to show two numbers at the same time, so all 6 possible outcomes are mutually exclusive from one another. The second requirement for all probability distributions is that the distribution shown must be collectively exhaustive. This means that the graph or chart has to somehow show all of the possible outcomes and the probabilities of all of those possible outcomes. Furthermore, all of those probability percentages have to add up to 1 or 100% because anytime this event occurs, the result must always be one of the outcomes shown, and it will never be another result or outcome that isn't represented on the graph or chart. Going back to our die example, this probability distribution shows all 6 possible outcomes and their probabilities, and is considered collectively exhaustive because there is no other possible outcome that isn't shown here. On top of that, all of the possibilities added together equals 1 or 100%, which means if you roll a die, there is a 100% probability that it will be one of the outcomes shown. Now, just to be clear, the probability distribution doesn't necessarily have to show every possible individual outcome. You can use ranges to represent a group of possible outcomes, and these ranges are referred to as distribution categories or distribution bins. Keep in mind that the ranges you use still have to represent all of the possible outcomes, and all of the probabilities still have to add up to 1 or 100% because the result must always fit into one of the categories or bins. Now, there are two different forms of probability distributions. The first is discrete probability, which the Institute defines as the probability distribution for a situation or risk where there is a finite or limited number of outcomes. Now, technically, that definition isn't 100% accurate to what discrete probability is, but for the purposes of your test, that's the definition that you'll want to remember. For discrete probability distributions that involve numeric results, the numbers will always be whole numbers because you can't have partial instances. For example, the number of accidents will always be a whole number because you can't have a fraction of an accident. In the context of risk management, discrete probability is typically used to show frequency distributions, meaning how often something will happen. The other form of probability distribution is continuous probability. This form applies to situations that have an infinite number of outcomes and does allow for decimal numbers. Continuous probability distributions will normally use countable bins with ranges to represent all the possible outcomes. These bins or groupings are called probability density functions and are often used to show severity distributions of how much damage you might potentially sustain from your losses.